It's not often we get to talk about deep space on this program, but for mere mortals like myself, this is beyond the realm of understanding. Exciting new images have been released from the recently launched James Webb Telescope. Joining me now to talk us through these new developments is astrophysicist, cosmologist, and a fellow at the Research School of Astronomy and Astrophysics at the ANU, Dr. Brad Tucker. Brad, thank you very much for your time. You must be over the moon and beyond Mars by about now.
Something like that. Yeah, it's been exciting to see these things. We've been waiting for so long. And so the wait has been growing. We've been waiting. And so it's an amazing event that it's happened. The engineering, the work, and now the science that begins because these images have been released.
All right, I'm going to open both hemispheres of my brain and try and conceptualise this. Explain to us how a telescope can snap images from history, from deep space and billions of years ago.
So the cool thing is, even though people are watching us right now, they're seeing us delayed. That's because it takes time for light to travel. When we look at the sun, we see it actually how it was 8 minutes ago. When we look further away, we look back in time because it takes that time for that light to travel. So when we saw that first image released of all of these clusters in a galaxy, we're literally seeing it billions of years ago. It's taken billions of years to travel through the universe and land on the camera of the James Webb Space Telescope. So you're seeing a snapshot of the true history of the universe. And so that's kind of the exciting bit of it, is the further back we look, the older we get, the different parts of the universe we can see, and then hopefully we can see more of the universe that we haven't been able to see previously.
I almost understand that. Now, let's bring up this latest image. What does this incredible sight tell us about the past in our universe? How close to the Big Bang does it bring us?
So look, the Big Bang was about 13.83 billion years. We're seeing galaxies around 13 billion years. So we're getting there.
Wow.
We're about 5 meters off from the touch line, so to speak. But that 5 meters left is the critical part, because we really want to see to that beginning when the first stars and galaxies have formed, because it took time for those stars and galaxies to emerge and then grow and change and evolve and die and eventually create. The universe recycles stars into new stars. And so by pushing that boundary back, we're really seeing the beginning of everything.
So what will give researchers a lot of information is many, many snapshots of different stages of the galaxies, of the stars, to work out exactly how they change, how they die, and how they live on. Am I right?
That's exactly right. Just as you can't wait to see how a human changes over time, but if we study a bunch of babies and toddlers and teenagers, we call teenagers the black holes, and then we got the adults and then, seniors, we can then pick a picture together of how humans change and grow over time. And that's the same thing we do with stars and galaxies. So it's the same process. And by looking at the millions and billions of them that exist, we can get an understanding of what the universe is doing.
What about life on other planets? I know everyone likes to take you in this direction. I'm fascinated by that. Have we got an... we've just lost... would you believe... See, that's life from other planets. It gets in the way. That's life from other planets. They've stopped somehow and we've lost Brad Tucker. I can't believe it. I wanted to ask whether any of these photos will eventually prove that there's life on other planets. And those on other planets don't want us to know this stuff. That was Dr. Brad Tucker.